Hi, welcome to this edition of GaryShort.tv. In this episode I catch up with Barry Carr, who tells us a bit about the Oxygene programming language. I hope you enjoy it.
Hi there, my name is Barry Carr and welcome to the screencast. Today I'm going to be talking to you about a language called Oxygene and one of its features called class contracts. This is going to be the first of a series of talks about Oxygene 3. Okay, so what's Oxygene? Well, Oxygene is a powerful Object Pascal based language that targets the .NET and Mono platforms. It's developed by a company called RemObjects, who also supply other libraries for .NET and Delphi. Oxygene has all the features of C# 3 plus many others, and these screencasts are going to be concentrated on these features which exist in Oxygene that C# 3 doesn't have. So, first of all, a little bit of background on class contracts. You probably know them by other names, the most common name being Design by Contract. Design by Contract was developed by Dr. Bertram Meyer for his language Eiffel. He did this in around about 1985-1986. Class contracts are based on the metaphor of a business contract, where all parties have obligations, and those obligations provide the other parties with benefits. The contract specifies how classes interact with each other, and we use assertions to specify the clauses of this contract. Another benefit of contracts is that they provide executable documentation within the code. So how are contracts specified? Well, most languages that support design by contract will provide you with three structures. A precondition structure, which is applied to methods, and this specifies how the method may be called and what values are legal for that method for it to return and execute correctly. Now, as you can imagine, this is an obligation on the client, the caller of the method, and it's a benefit to the class or the method itself, because it knows that it's going to get a sanitized and a sensible set of parameters for it to work on. The corollary to the precondition is the postcondition. This also applies to methods, and these are an obligation on the class and a benefit to the client. The benefit to the client is that it knows that the operation that it's asked for has been carried out successfully. Finally, we have invariants. Invariants are applied to the class, and they specify what the correct state for the class is at all times. Once the constructor has run, then the class invariants must be true, must always be correct. So how does this fit in with Oxygene? Well, Oxygene provides three structures. Preconditions are specified with a require clause, which you can place at the beginning of each method. Postconditions are specified with an ensure clause, which can be specified at the end of a method. And finally, we have the class invariant. The class invariants are specified in the class definition. Now we'll go straight to the code, and we'll be looking at a stack class that's been written in Oxygene that makes full use of the class contract features of Oxygene. In Visual Studio, before I go on to talk to you about class contracts in Oxygene, I'd like to explain a little bit about Oxygene's source format and general syntax. Now, source files in Oxygene are generally split into two parts. Here we are the interface section at the top, which is broadly analogous to a header file in C, in that any declarations that occur in the interface section are available to the outside world. And below the interface section we have the implementation section, which is where all the code goes. So all the code that for the stack declaration up here can be found in the implementation section here. Okay. So, going back to the stack declaration, we can see that it's a generic class. It uses a syntax very similar to C#, that is that type annotations go between angle brackets. Visibility clauses can work on more than one declaration. A visibility clause remains in effect until another visibility declaration is found, or we reach the end of the class. Like all Pascals, Oxygene follows the convention of variable name first, then type separated by a colon, and statements are separated by a semicolon, not terminated. This means that in some cases you do not have to supply a semicolon if you don't wish to. Constructors are nameless as they are in C#, and functions or methods are declared obviously with the method keyword, and if they return a result, then that is declared after the function name, in the same way that variables are declared. Properties, although they only appear to occupy one line, you can actually have arbitrary amounts of code attached to a property, like you can with a getter and setter in C#. This first property here is just a simple getter. It just returns the fcount field, and the second property here and the ones after refer to a function which returns the property's value. So in this case, the getItem here refers to this getItem method up here. And now finally we come to one of the first of Oxygene's class contract features, and this is the invariant for this class. Now, as I said in the introduction, the invariant clauses are just a simple set of assertions, Boolean statements. This one has 6, and these invariants will be tested before every method is executed and after every method is executed, and they are executed for the first time after the constructor completes. The last assertion is probably the most interesting one, in that we have this keyword here called implies. Now, effectively what this is saying is that if this part of the assertion is true, i.e. the stack isn't empty, then this part also has to be true. And what this second part here is effectively saying is that the item at the top of the top of the stack, the item that the user would see if they were going to pop the item off the stack, must be the same object that's at the fcount position in the backend store, which in this case is f representation.